Welcome to the deep dive. Today we're taking a slightly different path. We're looking at something you might not expect, excerpts from the PowerScale D-PSC-MN-01 exam practice questions.
Yeah, it sounds maybe a bit dry, but what's really fascinating is how these questions pack in so much practical, real-world knowledge. They're like little windows into critical scenarios you face with these big storage systems.
Exactly. So our mission today is to pull out those key insights for you. Think of it as a shortcut, really, to understanding the nuts and bolts, both physical and digital, of keeping Dell PowerScale infrastructure safe and sound.
We're basically decoding the exam prep to give you the essential info.
Right. It's like getting a behind-the-scenes peek at what keeps these massive data systems humming. We'll touch on hardware, maintenance, installation, implementation, all through the lens of these practical questions. Some surprising stuff in here, too.
Definitely.
So let's kick things off with hardware. There's this really fundamental difference that pops up right away in the questions, something that impacts service, uptime, everything.
You mean the CRUs versus FRUs?
Exactly. Customer replaceable units versus field replaceable units. Can you unpack that difference for us? Why is it such a big deal?
Sure. It's pretty straightforward, but really important. CRUs, customer replaceable units, are parts like, say, a power supply or maybe a disk drive that Dell has designed so you, the customer, can safely swap them out. No special technician needed, usually pretty simple.
Okay, toolless, maybe quick swap.
Often, yeah. The idea is quick recovery. Now, FRUs, field replaceable units, that's different. These are usually more complex, maybe more critical components. Think system boards, internal controllers, that kind of thing.
Wow. Okay.
For those, you absolutely need a Dell-certified technician. It requires specific skills, maybe special tools, and honestly, there's more risk involved if you don't know exactly what you're doing.
So it's not just about who can do it, but who should do it for safety and warranty reasons.
Precisely. It's about managing risk, ensuring the system's integrity, and yeah, warranty compliance is a big part of it. If you try to replace an FRU yourself and something goes wrong, that could be a costly mistake. Knowing the difference saves time and prevents problems.
Okay, that makes sense. Now, sticking with hardware details, one question pointed out something visual, a specific color on certain parts. A terracotta-colored handle on Gen 6 components.
Yes, the terracotta handle.
It sounds like just aesthetics, but the source implies it's a serious warning. What's the story there?
Yeah, it's definitely not just for looks. That terracotta color is a critical safety indicator. It means that component is absolutely not hot swappable.
Not hot swappable, meaning?
Meaning you must power the node down completely before you even think about removing or replacing that part. Trying to pull it while the system is live is a big no-no.
And if someone misses that, or just ignores the color, what happens?
Well, best case, maybe just an error. Worst case, you could cause an immediate, unplanned shutdown of the node. Potential data corruption if things aren't flushed correctly. You could even physically damage the component or the node itself.
Wow, okay.
It really underscores how important these visual cues are in complex systems. Attention to detail is key, especially in high availability environments where you want zero unexpected downtime.
So, given this complexity and the need for precision, if you do need to do maintenance, replace a part, fix something, where do you get the official, reliable instructions? The questions pointed to a specific resource, not just a general manual.
Right, and that's another key piece of the puzzle. The definitive source is Dell Solve Online. That's what the practice material highlights.
Solve Online, what makes it different from just like a PDF manual?
Well, it's much more interactive. It's designed to provide really specific step-by-step procedures, often with diagrams, tailored to the exact task and hardware model. It's not just static text.
So it guides you through it more actively.
Exactly. Think about how complex these systems are. There can be subtle dependencies, specific torque settings, sequences you have to follow. Solve Online aims to standardize all that, reducing the chance of human error.
Minimizing mistakes.
Absolutely. It ensures consistency, safety, whether you're an experienced field tech or someone doing a task for the first time. It's that single source of truth for critical procedures.
Interesting. Now, here's one that surprised me a bit, a hardware dependency. The sources mention that if you replace a backup battery on a PowerScale Gen 6 node,
I know where you're going with this.
you also have to replace the M.2 card at the same time. Why? They seem like separate things.
Yeah, it does seem a bit odd at first glance, doesn't it? But it points to how tightly integrated these systems are, especially around protecting data during power loss. The backup battery obviously provides that temporary power if the main AC fails.
Right, to keep things alive for a bit.
To allow the system to maybe flush its cache, save its state, that kind of thing, the M2 card, in this context, is likely storing something critical related to that process. Maybe system logs, maybe boot info, maybe even part of the cache itself that needs to be perfectly reliable alongside a fresh battery.
So they work as a team, essentially, for data protection during an outage.
That's the idea. Dell has determined that for guaranteed reliability and data integrity during that critical power loss event, both components need to be replaced together. Replacing just one could potentially compromise the system's ability to handle the next power failure correctly.
Okay, so ignoring that could lead to data loss down the line.
Potentially, yes. Or system instability upon recovery. It's a good reminder that you need to understand these interdependencies, not just treat components in isolation.
Makes sense. So let's say you do replace a whole node. It's failed, you swap it out. What happens to the parts from the old node? Do you keep them for spares? Toss them. The sources mention a specific process.
Right, the questions indicate a very clear process. For a single node replacement, the components from the old failed node are actually returned to Dell. It's part of the exchange.
Returned? Why?
Well, it's part of a bigger lifecycle management strategy. First, there's environmental responsibility, making sure complex electronics are disposed of or recycled properly. Second, data security. Dell can ensure any residual data is securely wiped or the components are destroyed.
Ah, good point.
And third, it helps maintain the integrity of their supply chain and warranty process. They can validate the failure, perhaps refurbish some parts if possible, or just ensure faulty or outdated components don't somehow find their way back into circulation.
So it's not just logistics, it's about control, security, and environment.
Exactly. It's responsible IT management for enterprise gear.
Okay, let's shift gears now. From maintenance to the very beginning installation. Before you even slide a node into the rack, the sources stress a crucial first step. What is it?
Something super fundamental, but sometimes rushed. Checking the physical site readiness. Dell provides a specific checklist for this.
A checklist. For what?
For the basics. Power requirements, cooling capacity, airflow, humidity, physical space, floor loading, all the environmental stuff. You need to confirm the site actually meets the requirements before you start installing the cluster.
It sounds obvious, but I guess it gets missed.
You'd be surprised. People get excited about the new hardware, but if the environment isn't right, you're setting yourself up for failure. Overheating, power issues, instability. It all comes back to that physical foundation.
So even the most advanced tech needs the right room conditions.
Absolutely. Neglecting that checklist is just asking for trouble down the line. It's foundational.
Speaking of physical stuff, how much space do these things actually take up? The source gave an example, the A3000 node.
Right, the A3000. That's a pretty dense storage node. It takes up 4 rack units, or 4U.
4U. Why is knowing that specific number, 4U, 2U, whatever, so important?
Oh, it's critical for planning. In a data center, space is usually at a premium. You need to know the exact U count for each piece of equipment to plan your rack layouts efficiently.
For fitting everything in.
Yes, and for ensuring proper airflow between devices. If things are too cramped, you get hotspots. Plus, power distribution. You need to know how many devices are going in each rack to calculate power draw and cooling needs accurately. Every U matters for density, cooling, power, and even just physically being able to install it.
Okay, makes sense. So the node is racked, power is good, environment is checked. How do you first talk to it? Like for initial setup or management, is it just any network port? The sources mention a specific one.
No, not just any port. For management, especially initial setup and ongoing administration, use a dedicated management port. On the F600 node, for example, the source points to the RNDC slot.
RNDC.
Yeah, Rack Network Daughter Card. It provides that specific port for what's called out-of-band management.
Out of band, meaning separate from the main data network.
Exactly. It's a separate dedicated network connection just for managing the device. This is a really important security and reliability feature.
That's it.
Well, imagine your main data network is having problems. Maybe it's congested or down or even, compromised by a security issue. If your management access relied on that same network, you'd be stuck.
You can get in to fix it.
Right. Out-of-bed management gives you a completely separate path. You can still log in, troubleshoot, reboot, reconfigure, whatever you need to do, even if the main network is offline. It's a lifeline to your critical infrastructure.
Okay, that's a crucial design element then. Now, let's move to bringing it all together, cluster operations. Once things are installed, you need to manage them, especially when issues arise. Say a node fails in an H500 cluster. Before you physically pull it out, the source says there's a command you must run.
Yes, absolutely critical step. Before replacing that failed node, the recommendation is to run EC status niche queue.
EC status niche queue, what does that tell you?
The deck queue makes it quiet. But the key is ISA status. It checks the overall health and, crucially, the available capacity of the cluster. You need to verify that the remaining nodes have enough free space to safely absorb and redistribute the data that was on the failed node.
Ah, so it's checking if the cluster can handle losing that node's capacity.
Precisely. If the cluster is already running too full, just pulling a node out could be disastrous. Data might not be able to be reprotected properly, potentially leading to data loss if another failure occurs, or the cluster might go into a read-only state.
So it's a safety check before you touch the hardware.
Exactly. It's proactive data management. Ensure the system can handle the change gracefully before you make the physical change. It's about preventing a bad situation from getting worse.
Got it. Last piece here. You've physically installed a new node, racked, powered, cabled, but it's just sitting there. How do you actually make it part of the working PowerScale cluster? There's a final command needed, right?
Yes, the physical install is just step one. To make it a functional part of the cluster, you need to run the isaddnode command.
Isaddnode?
That's the command that tells the existing cluster, hey, here's a new member. It officially joins the node, allows it to participate in the distributed file system, take on data, contribute to performance and protection, all of that.
So that command is what performs the logical integration. It turns it from a standalone box into part of the collective.
Perfectly put. The physical installation is necessary, of course, but it's the software commands, like isaddnode, that weave it into the fabric of the software-defined storage system. That's what creates the unified cluster, distributing the intelligence and the workload.
As you go about your day interacting with technology or any complex system, think about that. How many hidden checks, subtle cues, or mandatory procedures are working silently in the background to keep things running smoothly? What are the terracotta handles in your world? The seemingly small details that actually hold critical importance, that could prevent a problem or unlock a deeper understanding if you just knew what to look for.